So let's start with 2B.4 part 1, using inverse in context. So we're going to be working through a problem. And before we dive into this problem, you guys are going to walk me through how to solve the following 3 problems. The following 3 problems we all should be able to solve, okay? So we're in a math choir, which means that you guys are going to sing to me, not sing to me, but at least tell me what we're doing for my next steps. I will just sit here until somebody, more than one person, tells me what to do for the next step in order to solve for x. Is that understood? Okay. So starting with problem letter A. Starting at letter A, what is my first step? Say what? Even though you didn't say to both sides, I'm going to assume it's to both sides. Part 1. Okay. All right. Now, when I divide by a fraction, it's the same thing as multiplying by its reciprocal. Do you understand that? When you divide fractions, that means you multiply by the reciprocal. The reciprocal means that your numerator and denominator are switching places. So I divided by 1/2 on the left is the same thing as me multiplying by 2 on the right. Does that make sense? Because the reciprocal of 1/2 is 2. All right. So we're left with x equals what? 34. Okay. On to the next. What do I do here? You were supposed to go get your papers off the table. Investigation. You're undoing. Think about your sentence. If this was a math sentence, I would start with the last thing I wrote, right? And the last thing you would have done was multiplied by 3. So I would have to undo that multiplication by 3. And to undo that multiplication by 3, wrong table. Multiply, I would divide by 3. Okay? Why were y'all stuck? We just practiced. No problem. You just did. That retention is killing us out here, guys. All right, so we divide by 3, and that leaves us with x minus 4 squared equals 5. Now what do? I do what? Yes. And I'm going to square root to both sides, even though I only said square root. And I leave that as a square root because 5 isn't a perfect square. All right, what's left? I'm not going to say it to both sides. Did not. Okay, so now we're left with x equals 4 plus the square root of 5. And that is all I need to do. X is now by itself. Because it's not exact. And there's no need for me to do so. Good question. Unless it asks you to approximate, estimate, or round, the exact is what you're going to always give in it in most advanced math classes. All right. We just learned this. How do I solve? Thank you. Someone. Lock. And you're done. Maria said, "Go." I said, you saved the class. Together. All right. Again, these are things that we have to be able to do consistently. All right. I started this off intentionally just to make sure our brains are up and we're paying attention. All right, let's dive into our problem. All right, we're going to talk about contextual application. So basically, we're going to look at a real world example of where using inverse in solving equations come into play. All right, we're going to do a little popcorn reading here. I'll start off with the first sentence and then someone pop on in. Your guardians plan to move into a tiny home after you move out of their house. Pop. 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 Our popcorn is burning. Somebody read. Think that a tiny home can vary, although typical trailers are usually between 8 feet. Pop. We're done. All right. So we read. Now we're going to talk about and highlight key information from what we read. So based on what we read here, we can pull some information out, right? We know that we have a trailer that is 8 feet wide. So we have 8 feet wide trailer whole length. Additionally, we want to avoid 13.5, so they've decided to do what? 13 feet. And it says the length of a tiny home can vary, although typically trailer lengths are usually between 8 feet and 30 feet. So our lengths are varying. We don't have a set length yet, right? Our length is unknown. So based on what we read, we know that our width equals 8, our height equals 13, and our L is just going to be the length. People are weird. All right. Yes, agreed. Anything else that we can pull from here? Nope. Oh, we also know that L is between what? L is greater than or equal to 8, but less than or equal to 30. Cool. All right. So the first thing we're tackling here is that your guardians seek your advice about what kind of siding to install on the exterior walls of their tiny home. Your first step is to write a function for the maximum area of siding needed. Make sure to define your variables and state all your assumptions. Okay. So on your paper, I gave you a little box for you to draw your little tiny home, right? I don't have a box, so I'm going to draw it. But we're going to label, take what we know, and draw our tiny home. So we have our height is 13, correct? Our width is 8. And I learned to draw rectangles by prisms by reiterating the same to the best of my abilities and connecting them. Yes. Huh? We'll see. Okay. And then do we know our length? No, so it's just L. And we want to cover the sides. We're siding, right? So we are doing you get the gist of it. It's outside the building. In geometry, what is that called? Anybody? Everybody? Huh? What is it? What kind of area? Surface area. So we need to calculate our surface area. Surface area is just the sides. Your total surface area is your sides and your base. Y'all remember that from geometry? All right, so if I need to calculate the surface area here, I need to calculate all of my sides. Well, what are the measurements of my sides? What would be the area of each side? So the first side, what am I doing? How do I find its area? Length times width. For all rectangles, it's going to be length times width equals our area. So when we're looking here, my first little face is what? It's what? 8 times 13. And I have how many of those? 2. So I have 2 8 by 13s. Plus, what are the other ones? What are those? They're rectangles still. But what are their dimensions? It's 13 by what? L. It's just 13 by L, right? Because we don't know our length, right? And how many of them do I have? You're putting siding. Remember, it's surface area, not total surface area. So surface area is just your sides, not your bases. There will be 2 of them. And that would be 2 times 13L. Agree? Would that be our function? Yeah. Can I clean the function up, though? Yes. So what would our function clean up to be? 8 times 13. What is it? 104 times 2 is? What's 2 times 13? So here is our formula for our parents to figure out how much siding they need. I'm assuming they're going to put the siding and then cut out the holes for the windows and doors. And we're not going to worry about that because that's way more math than we want to do. All right, how do we feel about it? Does that make sense? Do we see how we took our math knowledge and applied it to a contextual situation? Yeah? All right. So the next part, it says, all right, your gardeners have researched several sidings materials and are available for a tiny home found in the following options. They have aluminum, corrugated steel, T111 wood, cedar wood, pine wood, and vinyl plastic. Work the partner. So you're not going to work the partner. I'm going to assign each one of your groups, and your groups are going to figure out the cost, the model for each one. Does that make sense? So group 1, you guys are going to figure out aluminum. Group 2, y'all are corrugated steel. Group 3 is T111 wood. 4 is cedar. 5 is pine. And 6 is vinyl. Okay? So for your assigned groups, you're going to figure out how much possible or what formula do you create for the parents to figure out their cost. Okay? That's what you're working. All right, guys, let's check back in. All right. Let's use a little bit of logic here. If I know the cost of something and I want to buy it in bulk, how do I figure out how much I'm going to spend? What operation do I use? Multiplication. If I know that something costs, if one of it costs $10 and I want to buy 100 of it to figure out and make a prediction of my cost, I'm going to take the cost of one and multiply by how much I need. correct? Yes. I'm going to take the cost of what and multiply by what I need. So I would take 10 times 100, and I know I'm going to spend $1,000, correct? Well, you already had your total amount that you needed. You need 208 plus 26 times L amount of material because that's the surface area you're covering. So if I tell you the cost, then you're taking this and you're multiplying it by that set cost. Does that make sense? So no matter what the cost is, this is what I'm taking it and multiplying what I need by what it costs. Okay? You're taking what you need and multiplying by what it costs. And then it says, and they're going to charge me for installation. Right? So your answers should have looked like so. If you were of aluminum, your final answer should have been 104x plus 1,632. And then corrugated steel, T111, cedar, pine, and vinyl. That's because you took what it cost and multiplied by what you needed. Okay. If your group didn't have it, do you understand it now? Yes. Okay. Please write down the correct one because you're going to need it for the next part. So for your group, write down the correct one if you have not written it down already. In my example up here, I use X instead of L because of course it said to use C of X. So I switched my L to an X because that's what it said for me to create. And you're going to work into the bill, filling in the table using your set equation. Okay. So based on the equation for your group, you're going to fill in. If they choose to have an 8-foot long trailer, what is it going to cost them? If they choose to have a 12-foot long trailer, what is it going to cost them? If they choose to have, you get it. So using your table, your group's value equation, did anyone need to go back for me to see to double check, or did we all write down our equation? Okay. So the beauty of an equation, you have the equation. Once you have the input, you just plug in and solve, right? And here are your inputs that you're plugging in and solve. And then we're going to look and see collectively what would be the best options for your parents tomorrow. All right, before you go, so that we're good to go, here are your values that you should have had depending on your. She said, you check. Sandra said, I'm checked out. I'll put it back up tomorrow. But if you have your paper out, these are the values you should have gotten for each one. Okay, so you're going to finish double checking your table. And then once you are done, you're then going to take your information and you're going to plot the points. Make sure you are determining your axes correctly, what you're going to count by and what each one represents is totally up to you at your group. And then as you're doing this, the graphs will vary, but we all know that they should be what type of graph should we be producing based on the type of equations that we got. So let's go back to the equations that we created. And when you look at these equations, what type of equations are they? It's pretty straightforward. So you'll fill that in. And then the last part is using your information. So using the table of values to estimate the maximum length of the tiny home you could buy, citing for, explain your reasoning. So your parents don't want to spend more than 6,000. And so based on that, what are the types of sightings that they could use? What link could they have based on the material your group was assigned? And then use your graph to estimate the maximum length of a tiny home you could buy siding for. So the maximum. So using your graph, what would be the maximum? So with the table, you're doing an estimate. And then with the graph, you're finding the exact. Okay. Now on here, Lady or Gardens share all the same thing. You're going to construct an equation you can solve to determine the length of a tiny home that matches the budget of 6,000. Okay. So you're going to explain your reasoning for that. Like, why do you think this is it? How would that work? And then you're going to solve your equation for X. You can also use a calculator to give a decimal approximation of your answer. Okay. Yeah. So you're going to finish out these notes, and then that will conclude our 4B.3, 4B.4, I'm sorry, part 2B.4, part 1 notes. All right.